Hello dear students, as you know that in the last classes I have started my discussion on the Fresnel class of diffraction. I have already discussed about the Fresnel half period zones in very details. We have also implemented the Fresnel half period zone to explain the diffraction in circular aperture and circular obstacles, and we have also discussed about the rectilinear propagation of light with the help of the Fresnel half period zones. So now we will be discussing about the zone plate, which is a direct consequence or application of the half period zones. তাহলে এই যে Fresnel's half period zones আমরা যা শিখেছি লাস্ট ক্লাসটাতে, whatever we have learned, so the direct application of the Fresnel's half period zone is that of a zone plate. As you know that when there is no obstacle and the effect of the entire wavefront at a particular point. So let me just try to drop off a diagram. So don't make the diagrams over here. So this is just a recapitulation of the last class, which I will go through and then I will start today's class. So this one was my actually a wavefront, and if I consider the effect of the entire wavefront, puro wavefront, that is there is no obstacle on it, so then we find that the intensity over here is given by A1 square by 4, where A1 is the contribution coming from the first half period zone. It was A1 square by 4, and then we have seen that if I block the first half period zone, so then the contribution comes out to be A2 square by 4. If I block the second one, it comes out to be A3 square by 4, and so on and so forth. We have seen the issues in the last classes. That is, as we block the number of zones, the intensity gradually decreases, and when we are able to block a number of zones, এবং যখন আমরা অনেকগুলো zones আমরা একসাথে block করতে পারি, whenever we can block a number of zones together, so then we actually call it that we don't find any intensity at the point P. Actually, we don't find any intensity at the point P, and this conclusively shows the rectilinear propagation of light, that is light travels in a straight path. And in the same way I have also shown to you that if you block the entire wavefront, যদি এরকম একটা অ্যারেঞ্জমেন্ট করতে পারি যে পুরো ওয়েভফ্রন্টটা আমরা ব্লক করে দিলাম, I block the entire wavefront, right? I block the entire wavefront, and suppose that পুরো ওয়েভফ্রন্টটা ব্লক করলাম, I block the entire wavefront, right? I block the entire wavefront and allow only the first half period zone to pass. শুধুমাত্র ফার্স্ট হাফ পিরিয়ড জোনটা যদি পাস করে, so then you have seen that the intensity over here comes out to be only A1 square, and that is 4 times that of the effect which you have found for the entire wavefront. For the entire wavefront it was A1 square by 4, but now it is only how much? It is A1 square if you allow only the first half period zone, and everything other is blocked. সবকিছু ব্লক করেছো, শুধু ফার্স্ট হাফ পিরিয়ড জোনটা অ্যালাউ করেছো, you have allowed only the first half period zone, so that then the intensity comes out to be A1 square, which is nothing but 4 times that of the entire wavefront. That means that the effect has increased drastically. So there has been an abrupt increase in the intensity. Intensityটা হঠাৎ করে অনেকটা বেড়ে গেছে. There has been an abrupt increase in intensity when you have used only one of the zones. So now this is quite interesting to note, and this conclusively shows that there is really interference, and that depends upon the path difference, that whether it is a constructive or a destructive interference. So তার মানে পয়েন্ট পি তে নিশ্চয়ই ইন্টারফারেন্স হয়েছিল, there is interference, and it is the destructive interference that has reduced the intensity to A1 square by 4. Actually intensity, if you just take the first half period zone, you take only one zone, the intensity is A1 square, and you take the total number of zones, you take all the zones, then it reduces to 1/4. So why does it happen? So this shows that there has been some amount of destructive interference, and that is why the intensity at the point P reduces, and this really proves the existence of the interference among the secondary wavelets from this particular wavefront. So that is the Fresnel's theory. So Huygens says that every point is a source of secondary disturbance, and Fresnel says that these secondary wavelets interfere among themselves, and this has been conclusively proved when you reduce the number of exposed half period zones. কটা জোনকে তুমি এক্সপোজ করবে তার উপরে এটা কিন্তু দেখা গেছে, and this has been shown experimentally. এটা কিন্তু experimentally proved একদম, this is proved experimentally that a very small aperture, the intensity is more. তুমি যদি এমন অ্যাপারচার করো very small in size such that only the first half period zone crosses it, so then the intensity is maximum at that particular point. So that has been shown, that has been proved. So today we will also try to extend these ideas, where we will cut out the amplitudes from the alternate odd zones or the even zones. So আজকে তোমায় যেটা আমি দেখাবো, তুমি জানো from the last classes you know that the net amplitude at a particular point is given by A1 minus A2 plus A3 minus A4 plus dot dot dot. So that is, there is alternate change of sign. Alternate change of sign is noticed over here, and this alternate change in size reduces the intensity. এবং এখান থেকে ইন্টেন্সিটিটা কিন্তু কমে যায়, and this actually shows that they come in opposite phase, and that opposite phase actually destructively interfere, and that is why you find the negative sign, and that is why the intensity diminishes at the point P. Now you see that if I can cut out any one of the particular sign terms, that is, suppose I cut out the negative sign terms, negative term গুলোকে আমি যদি কেটে বাদ দিয়ে দিই, if I reject the negative terms, so then you see it is only A1 plus A3 plus A5. So you expect a very intense point P. তাহলে তুমি কি এক্সপেক্ট করো? P এর ইন্টেন্সিটি অনেক গুণ বেড়ে যাবে, the intensity at P will increase to a very high level because you have obstructed the destructive terms. So যেই টার্মগুলো ডিস্ট্রাকশনের জন্য দায়ী ছিল, the terms which were responsible for destruction, those terms have been blocked over here, and you allow only which terms? Only the constructive terms, that is A1, A3, A5, and that is why the intensity at the point P will be very, very high now, because if you know that if you expose the entire wavefront, you know that it is how much? It is only A1 by 2. The amplitude is A1 by 2, intensity is A1 square by 4, so amplitude is only A1 by 2. But now you see that the amplitude is A1 plus A3 plus A5, and that is very, very greater. এটা অনেক বড় হবে, and the point P is a very highly focused and highly intense point will be capital P, if you can make such an arrangement. So এরকম arrangement যদি আমি করতে পারি তাহলে আমার এটা হবে, so then that will happen. Got the idea? And at the same time you can also block the odd terms also. তুমি odd terms ও block করতে পারো, মানে তুমি A1 A3 এগুলোকে block করে দাও, তাহলে তোমার কি হয়ে যাবে? So then if you just take the negative sign common, or the negative sign is of no use now, এখন আর নেগেটিভ সাইনটার কোনো ইউজ নেই, because all the terms are of similar symbol, প্রত্যেকটা টার্মই তো সেম ফেজে আছে, A2 and A4 are in same phase basically because both are negative. তাহলে এখন কন্ট্রিবিউশনটা কি হবে? It will be A2 plus A4 plus something dot dot, and that is definitely greater than A1 by 2, which you used to get when the entire wavefront is exposed. So the concept of zone plate is that you obstruct the alternate zones. So alternate zones গুলোকে obstruct করো, তাহলে পয়েন্ট P টা যদি দেখো যে সত্যিই খুব ইন্টেন্স পয়েন্ট হচ্ছে, it is a very intense point. So this one again conclusively proves the existence of the interference between the secondary wavefront. So this is another approach to prove the interference of the secondary wavefront. বুঝতে পেরেছো তো? বোঝা যাচ্ছে? একটা অ্যাপ্রোচ হচ্ছে হাফ পিরিয়ড জোন দিয়ে সিম্পল, যেটা আমি বলেছিলাম যে শুধু একটা হাফ পিরিয়ড জোন এক্সপোজ করলে যা লাইট আসবে, আর যখন সমস্ত ওয়েভফ্রন্টটা এক্সপোজ করবে, when you expose the entire wavefront, the intensity diminishes, ইন্টেন্সিটি কমে যাচ্ছে। কেন কমে যাচ্ছে? why decreases? Because of destructive interference, কেননা ওখানে destructive interference হয়েছিল। So that has been proved experimentally that the intensity really decreases, মানে whatever you obtain theoretically, the same you also obtain practically, that is experimentally. And here also the theory is designed, so মানুষ বলছে যে আচ্ছা ঠিক আছে চলো এইভাবে একটু করে দেখা যাক, so let us test in this way that if the entire wavefront is exposed, the intensity that you get, which is A1 square by 4 or A1 by 2 as the amplitude, and if the alternate zones are blocked, so then we expect less intensity, more intensity. If the alternate zones are blocked, that is you have contribution only from the positive terms, so this will be a very highly intense point. তাহলে অত্যন্ত intense point এটা আসবে, that should be a very intense point. And let us see that how it can be designed and if it happens really. So I would like to mention that this actually happened in real practice. তো সত্যিকারেই কিন্তু এটা হয়েছিল। The intensity at the point P increased drastically. প্রচন্ড পরিমাণে ইন্টেন্সিটি বেড়ে গেছিল। The intensity increased drastically when you have blocked the alternate zones. So let us deduce a proper theory of it, and then we will go for the other subsidiary issues. And if some time permits, I will also try to show you some numerical examples on these issues. Okay, so let us proceed. So I start with the zone plate, today's discussion. So here from, start taking the note from here, zone plate. এখান থেকে নোট লেখা শুরু করবে। Zone plate. The principle of operation of zone plate is based on the Fresnel's theory of half period zone. So let us write that first. The principle of zone plate, the principle of zone plate, the principle of zone plate is based on the Fresnel's theory of half period, Fresnel's theory of half period zones is based on the Fresnel's theory of half period zones. It is a type of diffracting screen. It is a type of diffracting screen used to stop the light. Diffracting screen used to stop the light from alternate half period zones. Used to stop the light from alternate half period zones. যেটা আমি আগে বলেছি, I have said. Now how can you construct this? এটা actually কি করে construct করা হয়? So the construction is something like this. So let us proceed with the construction. Construction point number 1. So point number 1 I write. It is constructed by drawing a number of concentric circles. It is constructed by drawing a number of concentric circles on a sheet of paper whose radii are proportional to the square root of natural numbers. Whose radii are proportional to square root of natural numbers. মানে হচ্ছে রেডিয়াসটা হচ্ছে প্রপোর্শনাল কার সাথে? The radius is proportional to square root of natural number. That means root over 1, root over 2, root over 3, root over 4, comma dot dot dot. So these are the radii. So এইটাকে radii নিয়ে তুমি সার্কেল আঁকা শুরু করে, you draw a circle with the help of your compass on a art paper. একটা আর্ট পেপারের উপরে ড্র করা শুরু করো। on a art paper you try to draw this type of circles. So পরপর আমরা সার্কেল ড্র করে গেলাম, হয়ে গেল সার্কেল ড্রয়িং। এইবারে the alternate zones are painted black. The alternate zones are painted black. Either 135 you paint black or 246 you paint black. করলে a photograph is taken. Okay, now here's something interesting. Photographটা তোমার ওই you cannot take it with the help of a digital camera. We don't use that. ওই মোবাইলের ক্যামেরা দিয়ে ছবি তুললে হবে না. So not with a digital camera or your mobile camera like that. So you have to use it with a negative plate, মানে old fashioned camera. That is you I think that you know it, তোমরা জানো হয়তো, or you may have seen it, some old photographs in your household activities. So বাড়িতে হয়তো কখনো দেখে থাকতে পারো যে একটা নেগেটিভ হয়। So a negative sheet is there. So a negative sheet is there and an image is recorded on that negative, and that negative is washed properly and that becomes a positive image. So ওটাকে নেগেটিভ বলা হয়। So these negatives are still days used in our laboratories, in our physics laboratories. So for crystallographic studies, মানে যেখানে ফটোগ্রাফ নেওয়ার ব্যাপার আছে, wherever you need to take photograph and to study it, particularly some x-ray diffraction and all those, so you use that negative plate. So ওই নেগেটিভ প্লেটটা আমরা ওখানে ইউজ করি, which is made up of basically silver bromide or something like that. ওরকম কম্পাউন্ড দিয়ে তৈরি হয়, and wherever light passes through it, it creates an image of it. So লাইটটা ওখান দিয়ে পাস করে ওর একটা ইমেজ তৈরি করে, it produces an image. So that is what is a negative. So I say that you take a photograph, but photograph is taken on a negative. একটা নেগেটিভ প্লেটের মধ্যে ফটোগ্রাফটা নিতে হবে, and that negative plate will behave as the zone plate over here. Hopefully you have understood. And okay, so a photograph is taken. I don't know that if you people have seen that negative plate or not, because 8 to 10 years ago when I used to teach all this, যখন 8-10 বছর আগে পড়াতাম তখন তো সবাই দেখতো, so people used to, so the students of those period have seen the negatives properly. Excuse me. But nowadays in the era of digital cameras and all this, I don't exactly expect that all of you have seen it. So if not, so then you just search in the Google. So একটা গুগলে সার্চ করে একটা নেগেটিভের ছবি দেখে নিও, ফটোগ্রাফ নেগেটিভ, you just search it and go for the Google images. I hope that you will come across some image. So কোনো ইমেজ তুমি ওখানে নিশ্চয়ই দেখতে পারো। So a photograph is taken and the negative thus obtained. and the negative thus obtained is a zone plate. নেগেটিভটা কি বলতো, ওই যে এক্স-রে প্লেট তো দেখেছো, এক্স-রে প্লেট এভরিবডি অফ ইউ হ্যাভ সিন আ এক্স-রে প্লেট। দ্য এক্স-রে প্লেট অলসো দ্যাট টাইপ অফ মেটেরিয়াল, নিয়ার অ্যাবাউট দ্যাট, এক্স্যাক্টলি ওই মেটেরিয়ালটা নয়। সো দেয়ার ইউ সি দ্যাট দ্য লাইট পাসেস থ্রু এন্ড ক্রিয়েট সাম ইমেজেস, তাই এক্স-রে প্লেট অর এমআরআই প্লেট, হ্যাঁ, সিটি স্ক্যান প্লেট, সো দ্যাট টাইপ অফ প্লেটস, ওরকম একটা প্লেট, ঠিক আছে। সো তুমি একটা ছবি তুলবে, ইউ উইল টেক এ ফটোগ্রাফ, বাট ইউ উইল টেক দ্য ফটোগ্রাফ উইথ দ্য হেল্প অফ এ normal camera, not the digital camera on a photographic plate, just like the x-rays, ওই x-ray প্লেটের মতন হবে। তাহলে প্লেটে তুমি এখন কি দেখতে পাবে, on the plate you will see concentric circles, সমকেন্দ্রিক তুমি দেখতে পাবে, হ্যাঁ, সমকেন্দ্রিক বৃত্ত, concentric circles you will see on the screen and alternates are black, এবং এক একটা তুমি দেখবে ব্ল্যাক আছে। so one of them is black and one of them is opaque, একটা opaque একটা black, একটা opaque একটা black, one is transparent, one is opaque, one is transparent, one is opaque, okay, so that is what you will see. A photograph is taken and the negative thus obtained is a zone plate, negative যেটা পেলে ওটাই হচ্ছে zone plate, just like the x-ray plate, okay, fine. And the next point we will go for, so next pointটা হচ্ছে, if the odd number of zones are transparent, মানে 1 3 5 you allow and 2 4 6 you block, if the odd number of zones are transparent, which we will actually follow here, and even number of zones are opaque, opaque means through which light cannot pass, opaque, then it is called a positive zone plate, then it is called a positive zone plate, okay. So if you allow the 1 3 5 7 this all and 2 4 6 8 are blocked, so then we call it a positive zone plate, right? However, a complementary situation is called negative zone plate. Complementary situation means, you understand, that is the odd number of zones are opaque, মানে 1 3 5 you block and 2 4 6 you allow the light, that is called the negative zone plate. But we will restrict our discussion to positive zone plates only. আমাদের ডিসকাশনে আমরা পজিটিভ জোন প্লেট ইউজ করব, that is 1 3 5 we will allow the light to pass and 2 4 6 will block the light, okay. So this is the basic idea that you have over here. তার মানে তোমার কাছে এখন একটা জোন প্লেট আছে, you have a zone plate with yourself, and each of these zones will act as the Fresnel half period zone, এবং এই জোনগুলো Fresnel half period জোনের মতন কাজ করবে। So the construction is over, now I will go for the theory. So construction হয়ে গেছে, এবার আমি তোমাকে থিওরি দেখাবো। So this is one of the expected question at the time of exam, that is either you may get half period zones, the concept of Fresnel half period zone and rectilinear propagation of light, either এটা একটা question হতে পারে, this can be a question, or the zone plate and multiple foci of zone plate, so that can be another question at the time of exam. So এই দুটোর মধ্যে একটা আমি expect করি you may get one of these at the time of exam, so prepare properly. And just do not rely on the notes only, the notes are just for your convenience. এখানে যা করে দেওয়া হচ্ছে সেটা তোমাদের সুবিধার্থে দেওয়া হচ্ছে, but you should write something else, okay, more or less মোটামুটি ঠিক আছে, চলো। Now here whatever I do is something like this. Oh, no, this is disturbing. Equal distance, not necessary equal distance নাই হতে পারে, it may not be equal distance, but I hope that it will be difficult to match up at the same point. সেই সেম পয়েন্টে মেলানোটা একটু মুশকিল হবে। Let me use the line feature of my software, আমি লাইন ফিচারটা ইউজ করি, let me use the line feature, it may help. Okay, the second one is also good, go for the third one. The third one also I am able to match, and this is the nth one, suppose. Okay, that's fine, that's fine. So I will put up the names over here. এখানে নামগুলো বসিয়ে দিই. This one is my EM1. In the half period zone class, it was so small that I couldn't put the names. Here I can do so. MN. Yeah, fine. This one is my some object, and this is the final focus point, which I call I. Because here you will see that there is some similarity with the convex lens formulation. So that is why I call it U and V. এটাকে U, এটাকে V এরকম ভাবে আমি দিলাম. So that is all I put, and this point is my P. Some object distance, image distance, everything will be clear with time. Time এর সাথে সাথে clear হবে, and these are the just rays of light. এটা light এর ray এগুলো. So these are the ray of light. So P to M1, this is your actually the first half period zone. Then M1 to M2 is the second half period zone, and then so on and so forth. So let me write it over here. I hope that the things will be understandable. So একটু করে লেখা শুরু করি, হয়তো বুঝে যাবে তোমরা. We have to determine the optical effect. We have to determine the optical effect. We have to determine the optical effect at capital I due to a light of wavelength lambda. Due to a light of wavelength lambda. আচ্ছা, একটা জিনিস মনে রাখো, you remember one thing, that the radii of the circles that I have drawn, so those are proportional to the square root of natural numbers. I will discuss the reason behind it. So কেন এটা হয়েছে আমরা বলে দেবো, হ্যাঁ, don't worry, I will discuss about it. So those who are having that question, I will clarify it. You will understand. So let OP equals to U and PI equals to V. So that is what we have taken over here. This is U and V I have taken. We consider points M1, M2, M3 on the plate such that we consider points, okay, I write this way, okay, M1, M2, M3, Mn on the plate such that on the plane such that OM1 plus M1I, OM1 plus M1I, right, minus OP or OI. I directly write OI. Now this difference is half a wavelength, lambda by 2. We just consider this. Then OM2 plus M2I minus OI, this one we consider to be some 2 into lambda by 2. And this one we just proceed, and OMN plus MNI minus OI, this one is some n lambda by 2. That is, you may suppose that the distance from one set to another set, the difference from one set to another set is of lambda by 2, right? That is the concept of half period zone. So অনেকটা দেখো half period zone এর মতন, from one to other it is lambda by 2 over here. So একটা lambda by 2 এখানে আছে, right? That is everything all about. So এই হচ্ছে তোমার পুরো সিচুয়েশনটা. And this black line is actually the zone plate. এই যে black line টা দেখতে পাচ্ছ, this black line, so this one is actually the zone plate. And on the zone plate you have considered some points M1, M2, M3, actually the zones from where light is coming, মানে যেই জায়গাগুলো থেকে লাইট পাস করছে সেই জোনগুলোর কথা বলা হচ্ছে. Those zones are here, M1, M2, M3. So light cannot pass through alternate zones. Alternate zone দিয়ে লাইট পাস করে না. So the zones through which the light passes, so those zones I have marked up over here, and I have placed the zone plate in such a manner, এমন ভাবে zone plate টাকে আমরা এখানে বসাবো, I will put it in such a manner such that this equation holds good, okay, such that this equation holds good. So once this equation holds good, the plane is divided into zone bounded by circles with radii, যেটা আমরা বলেছিলাম সেটাই এখানেতে দেখে নাও. The plate is bounded by, the plate is divided into what? Into zones bounded by circles, okay. The plate is divided into zones bounded by circles with center. with center. Where is the center? With center. Where is the center? With center at P. With center at P and radii. And what is the radii? And radii, the first one radii is PM1. Chalo, hate likhbo eta, I will write it myself. So with radii PM1, comma PM2, comma dot dot up to PMN, right? So this is my zone plate. This black line is the zone plate, and this zone plate, on this zone plate, you know that how did the zone plate develop? The zone plate consists of concentric circles. Zone plate er moddhe concentric circles ache and alternate circles are painted black. Ebong excuse me, alternate circles are painted black. So this is all about your, with radii PM1, I just make a change. Excuse me, don't curse me. I just need to make a change. PM1 is R1, PM2 I called R2, and then dot dot, and this PMN I call it RN. This is my RN. Fine. Now what happens from the figure? So look at the figure. From figure, what can you say? From figure you may conclude that OMN square, in general, OMN square is equals to, it's a Pythagoras theorem, OP square plus PMN square. Just have a look on the diagram. OMN square, that is the hypotenuse square, is OP square plus PM square. That's fine. Pythagoras theorem, আর কিছুই না. You take OP square common from here, so that gives you 1 plus কত আসবে? PMN square divided by OP square. ঠিক আছে, লিখলাম. You write it. Next you may write OP you have already taken to be U. OP টাকে already U নিয়েছো দেখো. So 1 plus, and this one you may write it Rn by U whole square to the power, no, nothing. So Rn by U, because this is Rn, PMN is Rn, and OP you have already taken to be U. So what is the value of OMN then? So OMN ta ki ashlo? OMN is U, and this one is 1 plus Rn square by U square. No need to write this whole squared format. So এইভাবেই থাক না, কি অসুবিধা আছে? This is to the power of half. Let us expand binomially and neglect the higher order terms. So সেটা লিখে দিচ্ছি, expanding binomially and neglecting higher order terms, because this U is very great in comparison to Rn. Rn to ki zone gulo radius. So the radius of the zones are nothing but they are equivalent to the wavelength of light. So wavelength dimension. But this U is the distance of the object. It object distance, image distance, something like that. The distance of the source from the zone plate, that is of the order of meter. It can be 1 meter or half a meter. So that is a great distance. অনেক বড় হয় ইউটা এখানেতে। আর Rn টা দেখো, Rn এর dimension, Rn is of the dimension of the wavelength, and this is of the dimension of 1 meter, something like that. So wavelength মানে 10 to the power minus 10 meter. Okay, so with respect to that, 10 to the power minus 10 meter and 1 meter, this one is negligible small. So that's why whatever I do is that expanding binomially and neglecting smaller terms. Expanding binomially and neglecting smaller terms, you may simply write over here. So এটা করলে তুমি লিখতেই পারো যে OMN is equals to U, and then you have 1 plus Rn square by 2 times of U square. 1 plus Rn square by this one. You can write it safely. Okay, fine, understood? Or you may write U divided by Rn square by 2 times of U. So that is your expression of OMN. And similarly you can also find IMN. তাহলে একই রকম ভাবে IMN টাও চলে আসবে, just U will be replaced by V. So let me write it similarly. So I write it similarly. Similarly IMN will be V plus Rn by 2 times of V. V plus Rn by 2 times of V. Understood? একদম প্রপার আন্ডারস্ট্যান্ডিং আছে। সো এটা যদি তুমি 1 নাম্বার ইকুয়েশনে বসিয়ে দাও, ইফ ইউ পুট ইট ইন ইকুয়েশন নাম্বার 1, আই ওয়ান্ডার দ্যাট হোয়ার ইজ মাই ইকুয়েশন 1। ইকুয়েশন 1 কোথায় আছে? এটাকে 1 বলছি, দিস ওয়ান আই কল 1. দিস ইজ দ্য জেনারেল ইকুয়েশন। So if I use the value of OMN and IMN in this particular equation, what happens is that using in 1, so let me write equation 1 একবার লিখি, OMN plus IMN minus of pi, most probably pi na oi ki chilo, oi, most probably oi, minus oi. That one was n lambda by 2 as we have assumed over here as per our requirement. So now this OMN is u plus Rn by twice u, IMN is v plus Rn by twice. Acha, this similarly you can do at the time of exam also. Okay, পরীক্ষার সময় ওই সিমিলারিটিটা করতে পারবে, you can write it safely. Minus OI, OI is again u plus v, তাই তো? OI, just have a look at the diagram. ডায়াগ্রামটা দেখে নাও, বুঝে যাবে what is OI. OI is u plus v, understandable, বোঝা যাচ্ছে, and that yields n lambda by 2. So safely this u plus v gets cancelled with this u plus v because of opposite sign. And if I take common over here, এগুলো Rn square ছিল most probably, yeah, this was Rn square, squared chilo, I missed it, Rn squared, so this will be Rn squared, I take common by 2, so it is 1 by u plus 1 by v. You see that this turns out to be the general formula of a convex lens and real image. So this u gets 2 gets cancelled, and you have 1 by v plus 1 by u is equals to n lambda by Rn square. And you know that this is the formula of convex lens for real object and real image. Convex lens, real object, real image. Actual formula তুমি বলবে যে স্যার এরকম ছিল, it was 1 by v minus 1 by u equals to 1 by f. But you know that for convex lens for real object, so তার মানে object distance is negative over here. The image is formed on the right side, real image, সদ প্রতিবিম্ব, real image. So for that's why your v will be actually negative. তার মানে v টা এখানে নেগেটিভ আসবে, right? Your v will turn out to be sorry. So v will be positive over here. So v টা positive থাকবে because it is on the right side. U will be, what will be u? U will be negative because it is on the left side. U টা negative হবে because it is on the left side. So that is why u will be negative. And this focal length will be positive because the second focus, if the parallel ray comes over here, it meets over here, so that is the second focal length. Actually f টা এখানে second focal length. I hope that these all you have studied in your school days, so nothing to be discussed. And this is most probably the new sign convention. I don't remember old sign and the new sign convention. Whatever convention I follow is, আমি যে conventionটা follow করি, that is, and that will really help you. So this is your graph paper. The left hand side of the graph paper is negative and the right hand side of the graph paper is positive. I don't follow that all those, okay, that along the direction of light, opposite to the direction of the light, right? So opposite to the direction of light is positive, along the direction is negative. This is most probably old sign convention, and the new sign convention is along the direction of light it is positive and opposite is negative, something like that. So many people follow that. Actually the textbooks follow that, but I would recommend always that instead of going into all difficulties ওই সব বাদ দিয়ে না, এখন একটা সিম্পল এরকম যদি গ্রাফ পেপারে যদি ভাবো, if you think of a graph paper, your left side is negative, right side is positive, top is positive, bottom is negative, and each and every problem can be solved with a very simple approach. একদম সহজভাবে তুমি সলভ করতে পারবে if you follow this approach, okay? Although this is geometrical optics is not required in the undergraduate course, but sometimes you may need it. Actually someday you may become a teacher and you may need to teach the higher secondary students, so then you may follow this convention, and I hope that you will definitely enjoy it. So যদি তোমার বাঁহাতে পড়ে লেফট সাইডে নেগেটিভ নাও, ডানহাতে পড়লে পজিটিভ নেবে। তাহলে এখানে কনভেক্স লেন্স রিয়েল ইমেজের ক্ষেত্রে, ফর দ্য কনভেক্স লেন্স রিয়েল ইমেজ, দ্য অবজেক্ট ওয়াজ অন দ্য লেফট সাইড. You can look at this diagram also. এই ডায়াগ্রামটাও দেখতে পারো, the object is on the left side, so that's why u is negative and all other terms are positive. So if I take this u to be negative, so this negative and negative makes it positive, so that is 1 by v plus 1 by u equals to 1 by f. So whatever you obtain on the screen right now, তাহলে যেটা এখানে আছে, so that is the equation of a convex lens real image. So this one I call it equation number 2, and you see that this shows the strong focusing action of a zone plate. তাহলে zone plate এর যে সত্যি একটা focusing action আছে সেটা দেখো এখান থেকে কিন্তু ক্লিয়ার হয়ে যাচ্ছে, it is clear from here. So I write it over here, and then I will go for further discussion. Equation 2 clearly shows কি দেখাচ্ছে? equation 2 clearly shows that এটা 2 নয়, এটাকে আমি 3 বলছি, দাঁড়া, এটাকে আমি 3 বলছি, এটাকে আমি 2 বলছি, this one I call 2. আচ্ছা, equation 2 থেকে দেখো, equation 2 clearly shows that Rn is proportional, clearly shows that Rn is proportional to root over n. Just have a look. This is Rn square and this is n, right? So from here you understand that Rn is proportional to root over of n. Rn is proportional to root over of n, right? Rn is proportional to root over n. So this is the reason that in order to design the zone plate, you have taken the square root. You have taken the radius of the circles to be proportional to square root. সেই জন্য নিয়েছিলে, ঠিক আছে? আচ্ছা, comparing with the standard equation of convex lens forming real image, you can write the focal length to be like this. Comparing with the standard equation of convex lens forming real image, forming real image, comparing with the standard equation of convex lens, comparing with the standard equation of convex lens forming real image, what happens? Forming the real image, what happens? Comparing with the standard equation of convex lens forming real image, you have the focal length to be equals to, so 1 by f, this one is actually 1 by v plus 1 by u equals to 1 by f. So focal length comes out to be Rn square by n lambda. So if you compare it with the focal length, so then you get something of this nature, right? So focal length of a zone plate can be evaluated from these particular equations. So now there is something to discuss. So ever discuss করার কিছু কিছু জিনিস আছে যেগুলো আমরা এখানে ডিসকাশনটা করব. So this is what I will be discussing next with you. So next I will be discussing that what is the intensity at this focusing point. So এই focusing point এর intensity টা কত হবে সেটা আমরা next discuss করব, and we will be also discussing about the multiple focus of a zone plate. Multiple focus of a zone plate will also be discussed over here. I hope that the things you have understood properly. So now let us go for the second part of this particular discussion. Okay, so next we will be discussing about the focusing axle of this particular zone plate. So let us write it as I have said that the alternate zones are blocked. So let us use the concept. So if the alternate zones are blocked, in a zone plate, and as I have said that I will be blocking the even number of zones, that is it will be a positive zone plate. If the alternate zones are blocked in a zone plate, comma, so then what happens? So then the resultant intensity, then the resultant amplitude, you may say, amplitude or intensity. So let me first of all write amplitude. So then the resultant amplitude at capital I will be how much? The resultant amplitude at capital I will be how much? So that will be given by this one. A equals to, you know, it is A1 plus A3 plus A5 plus dot dot dot. So that is the concept of the zone plate. You know, this is the concept of the half period zones, and the even zones are just omitted from here. So even zones গুলো এখান থেকে omit করা হয়েছে। তাহলে কি শিখলাম? So what will happen to the intensity? Will it increase or decrease? So definitely the intensity will drastically increase because you have blocked the alternate zones. The negative contributions are blocked. So the resultant intensity, amplitude or intensity, so the resultant intensity will be extremely high. This is a very important word, extremely high. The resultant intensity will be extremely high if the contribution will be extremely high if the contribution from the alternate zones, will be extremely high if the contribution from the alternate zones are only taken instead of taking all the half period zones, thus a zone plate behaves as what? Behaves as a convex lens. Thus the zone plate behaves as a convex lens of focal length. Already we have studied it. Thus the zone plate behaves as a convex lens of focal length, as I have already deduced, of focal length Rn square by n lambda, right? So this is how the convex the zone plate behaves as a the zone plate behaves as a convex lens whose focal length is given by this particular term, right? And you see that if you put over here n equals to, so from here many people actually they are misguided. অনেকে মনে করে কি যে f এর অনেকগুলো ভ্যালু হয়, so many people are misguided by thinking that the focal length has many different values. So many people actually write this to be fn, অনেকে এটাকে fn লেখে, some people write it fn, right? And then they used to write f1 is equals to r1 square by lambda, they used to write f2 equals to r2 square by some 2 lambda, and then they used to write f3 equals to r3 square by 3 lambda. But you see that they are writing wrong, তারা কিন্তু ভুল লিখছে. So a zone plate doesn't have the different focus over here. So zone plate এর এরকম different focus হয় না. The zone plate doesn't have different focus in this particular formula. According to this particular formula, the zone plate do not have different focus. It has only one focus only according to this formula. Why? It apparently appears that these are different. মনে হচ্ছে এগুলো আলাদা, but you believe that these are all same, and this can be easily understood by you. You remember that somewhere you have written that your radius is proportional to what? It is proportional to the it is proportional to the natural numbers. So the radius you can safely write to be some k into n rn square. Rn square কে আমি কি লিখতে পারি? K into n লিখতে পারি তো? I square both sides and k is the proportionality constant over here, right? So if I write for r1, আমি যদি r1 এর জন্য লিখি তাহলে এটা কি হবে? So this will be, I use 1, so this will be k by lambda. Understood properly? বুঝে নিয়েছো প্রথমে? It will be k by lambda. Now you suppose that you write it for some this r2. So if I use 2 over here, so এখানে যদি 2 use করি, so then it will be some 2k. So it will be some 2k, and in the denominator you have 2 by lambda, and look at the beauty that it comes out to be k by lambda. And similarly if I use 3 over here, so r3 square is 3k, so 3k divided by 3 lambda, so this again comes out to be k by lambda. So I have seen many textbooks, particularly a few books which are designed for the CBCS course, a very poor book, very bad quality book, undergraded, খুবই বাজে কোয়ালিটির কিছু বই আছে যারা এই সমস্ত লিখে, the authors write, I wonder that how do they write all this. But still I have found some books like this, particularly the books which are designed for the CBCS curriculum. So I just request you to avoid those texts. এগুলো কিন্তু পড়বে না, কারণ দেখো ভুল কথা বলেছে। এইটা দেখেই অনেকে বলেছে, many people say that zone plate has multiple foci. Yes, I agree that zone plate has multiple foci, and that is what we are going to study next. And if zone plate is a question at the time of exam, so then that will be an additional question definitely. Zone plate যদি পরীক্ষায় আসে, first of all they will ask you the formula, the focusing action and all this, and then they will say that explain the term that zone plate has multiple foci. Just like if the Fresnel half period zone is a question, so then the tail question will be, so তার সাথে একটা question থাকবে explain rectilinear propagation of light. So that note has been provided to you. Similarly here also I will provide you the material to understand that zone plate has multiple foci. একটা zone plate এর অনেক ফোকাস থাকে। You read from your book the difference between zone plate and convex lens. I repeat, difference between zone plate and convex lens. বাড়িতে বই থেকে পড়বে, you take the difference of it. The difference. One of the difference is that convex lens has only one and only one focus. Convex lens এর কিন্তু একটাই ফোকাস থাকে। ওই দুদিকে দুটো ওইটা না, only the right side you consider the second focus actually. So if the parallel rays are incident, then it will be focused at a point, and that is known as the second focus point. So a convex lens has only one focus point, only one focal point, right? But a zone plate has multiple focal point. Zone plate এর অনেকগুলো focal point থাকে, but সেটা এইভাবে নয়. So the explanation is not this. The explanation is not this, that fn equals to rn square, because you see that this is not fn, all the values are same. এখানে তো f1 এরও যা f2 ও তাই f3 ও তাই না? So this is not that, right? So according to this formula, the zone plate has only one focus till now. But how the zone plate can have multiple foci, zone plate এর কি করে multiple focus থাকতে পারে, that is a different issue, and that I will be discussing with you next. সেটা আমি তোমাদের সাথে এর পরে আলোচনা করছি, ঠিক আছে? চলো নেক্সট চলো, let us move on. একটু সাবধানে থেকো, হ্যাঁ, beware of those textbooks. আচ্ছা, so just I put a problem over here, a very straightforward problem. একটা straightforward problem এখানে আমি দেখাচ্ছি তোমাকে। So সেটা হচ্ছে a zone plate is to be constructed, a zone plate is to be constructed, a zone plate is to be constructed with focal, a zone plate is to be constructed with focal length 50, with focal length 50 centimeter for wavelength for wavelength how much 6000 angstrom, for wavelength 6000 angstrom. Okay, 6000 angstrom. Calculate the radius of the first zone. Calculate the radius of the first zone. A very simple problem, বুঝতেই পারছো একদম সোজা সাপটা ডাইরেক্ট প্রবলেম একটা দিয়েছি। I have provided you a very direct problem. Zone plate is to be constructed with focal length this one, for wavelength this one. Calculate the radius of the first zone. First zone এর রেডিয়াসটা বের করতে হবে। So this is a very direct formula over here. So using the direct formula you can write over here that the focal length is given by, don't write fn, fn টা মুছে দিতে হবে, I should remove fn. This is the focal length only. So Rn square by n lambda. Okay, so that's my direct formula, Rn square by n lambda. And I need to find the value of Rn over here, and I need to find actually R1, the radius of the first zone. So the radius of the first zone is f lambda root. Okay, f lambda root. So that is the radius of the first zone. Okay, and if it is the nth zone, so then what is the formula? Nth zone হলে ফর্মুলাটা কি আছে বলো? nf lambda. You may write that one also. First of all ধরো এটাই লিখলাম, Rn equals to nf lambda. তো তুমি কি বুঝতে পারছো? Can you understand? This is some k into root over of n. Is it clear to you that the radius is really proportional to some square root of natural numbers? This f is a constant and lambda is a constant for a particular zone plate. At a particular zone plate f or lambda তুমি যদি constant নাও, so then it comes out to be root over of n, right? So from here you may safely write that this R1 is equal to root of f lambda. So R1 টা হচ্ছে root of f lambda. তাহলে এখানে f এর ভ্যালু তুমি জানো, you know the value of f and you know the value of the wavelength, so you can easily calculate this out. So the f is here 50 centimeter and this 6000, this one will be in, if I write it in centimeter then it should be 10 to the power minus 8. So that is in the centimeter scale. So this comes out to be 0.055. Please calculate this one. একটু ক্যালকুলেট করে দেখে নিও, 0.055 centimeter. Okay, 0.055 centimeter is the radius of this first zone. Okay, let me show you another problem very quickly. আর একটা প্রবলেম আমি দেখিয়ে দিচ্ছি। So these problems actually are set in different examination. Radius of 8th zone of a zone plate, radius of 8th zone of a zone plate, radius of 8th zone of a zone plate is 4.5 millimeter, is 4.5 millimeter. Find the focal length of the plate. Find the focal length of the plate for lambda equals to 650 nanometer. Find the focal length for lambda equal to 650 nanometer, right? And here you write also find the position of the image. Also find the position of the image if the source is 7.78 millimeter away from the plate. 7.78 millimeter away from the plate. Also find the position of the image if the source is 7.78 millimeter away from the plate. Okay, find the focal length of the plate for lambda equals to this. So this focal length I am not going for it. Focal length you can calculate very easily. There is a direct formula, Rn square by n lambda. So here the Rn is given most probably, yes, 4.5 millimeter. So I write it 4.5 into 10 to the power minus 4 or 10 to the power minus 3 hobe if I convert it into meter. So 4.5 into 10 to the power minus 3. So this one whole square. In the meter scale I am doing. N is 8 and lambda in the meter scale will be 650 into 10 to the power minus 9. এত মিটারে আছে এটা, so this is in meter. So if you just calculate this, this comes out to be some 3.894. So এটা এরকম আছে 3.894 this one meter. If you just go for it. And then the last part I am interested. So also find the position of the image if the source is this much away. So you recall this formula. So there is a formula to calculate the object distance, image distance. 1 by v plus 1 by u equals to 1 by f. So over here you may just use the formula that 1 by v comes out to be 1 by f minus of 1 by u. Now 1 by f is 1 divided by 3.894 and this u will be over here. So u jeta ache the object distance, so that object distance will be 7.78. 7.78 millimeter chilo ota. So oh eta millimeter na, sorry, this one is meter. So 7.78, right? So you just calculate this one. So এটাকে just যদি আমরা calculate করে ফেলি, if I just try to calculate this one, So I guess that you will get your result from here. Just wait for a minute. Okay, this one is 7.78. This one is actually 2 minus 1, I guess. Nearly 3.894 কে 2 দিয়ে মাল্টিপ্লাই করে দেখো তো, 3.894 multiplied by 2, yeah, this gives you 7.788 actually. Okay, so this is nearly this is 7.788. This question I have written some, এটা একটু প্রবলেম হয়ে আছে, so 7.788 like this, that's fine now. So therefore we understand that v comes out to be 7.78 meter. So v comes out to be 7.78 meter. Okay, so the object distance and the image distance is the same. So the object distance and the image distance is the same in this particular problem, right? So this is what I needed to show it to you, and I have been successful in doing so. তো সেটা তোমাদেরকে দেখানো হয়ে গেল, এই যে দুটো প্রবলেম আমি যেটা দেখাতে চাইছিলাম। আচ্ছা, এবার হচ্ছে ফোকাই as a zone plate. So now I will be discussing about the foci. Sorry, foci, ব্র্যাকেটে we write multiple foci. Foci or multiple foci of a zone plate. Foci or multiple foci of a zone plate. Foci or multiple foci of a zone plate. So what do we mean by that? Multiple foci of a zone plate. So multiple foci of a zone plate, এই ব্যাপারটা কি? So what is that? Multiple foci of a zone plate. So here you recall some issues, that recall 1 by v plus 1 by u is equals to 1 by f. Okay, this is the general formula. And now you suppose that the light is incident on zone plate. Light is incident from zone plate coming from infinity. Okay, light is incident on zone plate coming from infinity. So that means that u is tending to infinity. You have done this type of problems in your higher secondary classes. So therefore your v comes out to be f. So this actually conclusively shows that your image is formed at the focal point. So এখান থেকে বোঝা যাচ্ছে যে ইমেজটা ফোকাল পয়েন্টে তৈরি হবে. So you understand that the image is produced at where? The image is produced at the focal point. Understood? The image is produced at the focal point, right? And we also know that this f turns out to be Rn square by n lambda. And f is equals to, we already know that your f turns out to be Rn square by n lambda. এটা হচ্ছে তোমার এটার ভ্যালু ছিল। তাহলে আমি এখান থেকে লিখতেই পারি, we can safely write that your v comes out to be Rn square by n lambda. ঠিক আছে, আবার তুমি এটাও জানো, you also know that your Rn square is equals to what? Your Rn square, you may again write it to be some Rn টাকে লিখতে পারো তুমি actually this Rn. Okay, Rn is proportional to what? Rn is proportional to square root of some natural numbers. Rn is proportional to square root of some natural numbers. This one I will write later on. It একটু পরে Rn square by n lambda. And you may write the net intensity or amplitude, net amplitude লিখি, net amplitude at capital I, and net amplitude at capital I, I suppose it to be net amplitude at capital I. So what will be that? You know that it is A1 plus A3 plus A5 plus dot. So this is what we have studied so far. So এইটুকু অবধি আমরা এখনো অবধি শিখেছি. So this is what we have studied so far, right? So just let me block it. Just excuse me, something has happened. Okay, the system has experienced some difficulty. Let me rerun it. Hopefully, I will recover the things. Yeah, so I have just recovered all my issues. That's fine. That's fine. I have recovered the issues over here. And now let us just this one. The net amplitude is this one. Fine. Okay. Now you may write this this Rn, as you know that it is proportional to the natural numbers. So we may write it in this way, that now Rn is proportional to some root over of n, as you used to know, or it is very much clear from this relation also. So এই relation থেকে এটা পরিষ্কার যে Rn and n, Rn square and n are proportional, so Rn is proportional to root over of n. Now this proportionality we may remove with the help of a constant. So I just take it to be some k times of root over of n. So I write it in this particular way. ঠিক আছে, সো এইভাবে আমরা লিখলাম। তাহলে এখান থেকে আমাদের r1 টা কি আসবে? হোয়াট ইজ দ্য রেডিয়াস অফ দ্য ফার্স্ট জোন? সো হিয়ার r1 কামস আউট টু বি সিম্পলি স্ট্রেট ফরওয়ার্ড k, and I box it over here, এবং এটাকে আমি বক্স করছি। and you will understand the importance of this relation, right? so far I did not introduce anything new to you, নতুন কিছু ইন্ট্রোডিউস করিনি। whatever I already had with me, so I have just implemented them in a proper manner. সো আমার কাছে যা কিছু আছে সেটাই আমি এখানেতে আরেকবার এখানে লিখেছি, নতুন কিন্তু কিছু করিনি। আই ডিডন্ট ডু এনিথিং নিউ ওভার হিয়ার সো ফার। তাহলে এখন আমি নিশ্চয়ই লিখতে পারি, সো আই ক্যান রাইট ওভার হিয়ার দ্যাট সো your v equals to some pi, right? so এটা pi ছিল, so v equals to pi over here. this pi, so v equals to pi is what is the value of v? That is pi, right? vi is p over here. And if I put 1, n equals to 1, you see that this relation is independent. এটা আমি বলেছিলাম। So whatever I write v is nothing but f. V and f are same over here because I have taken the object at infinite distance. So you have seen that v and f. And just now I have shown you, একটু আগেই তোমাদের আমি দেখিয়েছিলাম that whatever be the value of n, the value of f comes out to be same. মানে আমি যদি এখানে r1 নিই তাহলেও যা f এর ভ্যালু হবে, আর আমি যদি r equals to 2 নিই, if I take r n equals to 2, then also you get the same value because proportionally this n and rn will be alternatingly changing. So সেটা চেঞ্জ করে এইভাবে জিনিসটা তুমি পাবে, right? So that is what is going on. So as n is increasing, Rn is also increasing. n যেমন বাড়ছে, Rn ও বাড়ছে। n is increasing, Rn is increasing, such that this ratio is always a constant, and that constant is this particular constant, এবং সেটা হচ্ছে এই কনস্ট্যান্টটা, nothing more than that, right? তাহলে v মানে আমাদের এখানে pi, আর I can safely write it to be some, you may write Rn square by n, anything you may write over here. So Rn যদি লেখো, so this comes out to be some k square into n, so I may write it some k square into n divided by n lambda. So this gets cancelled and you have simply k square by lambda, right? So the value is k square by lambda. So v এর ভ্যালু আমার কাছে আসলো k square by lambda. Okay, so this is the position of the point I. This is the position of the point I. Okay, I just draw a rough diagram for our understanding purpose. আমাদের বোঝার জন্য আমরা জাস্ট একটা ড্র করে রাখি। This is the zone plate, and the light is coming from infinity, so those are parallel beams, and here I have the point capital I. এখানে capital I পয়েন্টটা আমার ছিল, right? So that is what I understand. এইবার যেটা আমি করব, now whatever I will do is that I will shift the point of observation to some I dashed. আমি এটা নিয়ে আসলাম একটা I dashed পয়েন্টে, I get it to the point I dashed. So let me write it. Let the point of observation be taken closer to the plate to I dash. Let us take the point of observation. Let us take the point of observation closer to the plate. Let us take the point of observation closer to the plate at I dashed, such that, so I take it in such a manner such that your pi dashed, মানে এই যে রিলেশনটা, this pi dashed will now be equals to some k square by 2 lambda, মানে আমি হাফ ডিস্টেন্সে নিয়ে এসেছি, I got it to the half distance. Okay, previously this v was how much? It was k square by lambda, but now I take it to some k square by 2 lambda. কিন্তু এখন আমি এটাকে কোথায় নিয়ে আসলাম? I take it to the point of k square by 2 lambda. I hope that you have understood it. আশা করি নিশ্চয়ই বুঝতে পারলে কি বলতে চাইছি। You have understood these issues over here. Okay, k square by 2 lambda. Fine. Now this pi dashed, if I write it some k dashed square by lambda, মানে if I want to maintain parity with my previous pi, আগের pi টার মতনই যদি আমি এটাকে লিখতে চাই, আগের বার pi টা কি ছিল? What was the value of pi last time? The value of pi was how much? What was the value of pi? It was k square by lambda. Now I shift the point I to I dash. So that is why now this one, if I want to maintain parity with this relation, এই রিলেশনটার সাথে যদি parity maintain করতে চাই, if I want to maintain the parity, so last time it was I, so it was k, and now it is I dashed, so this k will be changing to k dashed. Lambda will be unaltered, right? So কেউ যদি জিজ্ঞাসা করে যে এই রিলেশনটা স্যার কোথা থেকে পেলেন pi dash equals to this, so I will simply say that when it was pi, যখন pi ছিল, when it was pi, it was k, so now you have changed the distance over here, so this one was your point p, so now you have changed the point from I to I dash. As you have changed it, so definitely this constant will change, so definitely this constant will change, and I call it k dash square by lambda, right? And this is something of k square by 2 lambda, মানে আগেরটার রেসপেক্টে this side gives you, this value gives the value of I dash independently, এটা I dash এর independent value, the left side, and right side is the value of I dash with respect to I. I এর রেসপেক্টে I dash টা কোথায় আছে? With respect to I dash, the position of I, that is given on the right side, and the left side gives the independent position of I dash, but both of them are the position of I dash, so they are equated, সেই জন্য তাদেরকে আমরা ইকুয়াল করেছি। So here from you can write it safely to be some k dash is equals to k by root over of 2. So k dash equals to k by root over of 2. You can write it over here, right? Understood? তাহলে এখান থেকে r1 dash টা কত হবে? So what will be the value of r1 dash from here? So this is with respect to the dashed point. So এখন কিন্তু dash দিয়ে লিখতে হবে, হ্যাঁ? So you have to write it with dash. So প্রথমত এখানে লিখতে হবে rn dashed. Last time what was rn? Rn was proportional to root over of n, but now it is rn dashed, and that will be equals to k dash times of root over of n. Got my point? বুঝতে পেরেছো? rn was k into root n, but r dash will be k dash times of root over of n. Just the point is replaced with the dashed point, ওটাকে dash দিয়ে replace করা হয়েছে। তাহলে এখন তুমি আমায় বলবে, so now you will say that how many radii are possible over here. So now rn dash I can write, what is the value of k dash? The value of k dash is k by root over of 2 into root over of n, and therefore you may say over here that r1 dash is equals to, যদি 1 বসাই তাহলে কত আসবে? It is k by root 2. If I use r2 dash, so then it comes out to be 2 বসালে it comes out to be k. Okay, understood, right? Now you just box up this relation, এই রিলেশনটাকে খালি বক্স করো, r2 dash এইটাকে বক্স করো, and now you try to compare these two relation. Compare this relation, I don't know what is the equation number over here, কত দেওয়া উচিত, let me put 1. This is equation 1, when the point of observation was I, and this is equation number 2, when the point of observation is I dash. Understood? So once it is I, when the point of observation is I have at k value, মানে k দূরত্বে, at the value of k I have only r1, at the value of k I have only r1. So ধরে নাও এটা হচ্ছে k value, suppose up to here you have k, okay? So up to k you have only how many? You have only the first zone, তাহলে এইটুকু জায়গাতে k আছে, first জোনটা আছে, that is r1 is present over here. Understood? But now you see at the value of k how many zones are there? দেখো কি beautiful, look at the beauty of it. Now at the value of k you have two zones over here, r1 dash and r2 dash, এই সেম ডিসটেন্স k তে, কিন্তু তার মানে এখানে আরেকটা জোন কিন্তু আসবে। So previously at the value this k value you have only r1, but now at this within this k value you not only have r1 but you also have a r2, একটা r1 ও আছে একটা r2 ও আছে, right? But when the point of observation is shifted where? When the point of observation is shifted to I dashed. Understood the issue? আশা করি কেসটা তুমি বুঝেছো। সো উইদিন দিস ভার্টিক্যাল ডিস্টেন্স কে previously you used to have one half period zone, but now you have more half period zones as you are shifting, as you are coming closer to this point of observation. যত ক্লোজ আসছো তত এখানেতে তুমি বেশি জোনস তুমি পাবে। Got my point? Is it clear? Now the idea is whether the intensity increases or decreases due to this. এই ঘটনাটা হওয়ার জন্য intensity at the point I dash will increase or decrease. So that is what you think yourself. সেটা তুমি ভাবো, ততক্ষণ আমি কিছু একটা লিখি। Let me write something. So within the first half period zone, half period zone মানে হচ্ছে with respect to I. So within the first half period zone, এখানে লিখে দিচ্ছি with respect to I, the half period zone with respect to I. So within the first half period zone বা within the first half period zone লেখা দরকার নেই, within the first transparent circle বা ট্রান্সপারেন্ট জোন লিখি। উইদিন দ্য ফার্স্ট ট্রান্সপারেন্ট জোন উইথ রেসপেক্ট আই, মানে দ্য জোন উইথ রেসপেক্ট টু আই, ওখানে এখন কি হয়, উই হ্যাভ টু হাফ পিরিয়ড জোন। সো উইদিন দ্য ফার্স্ট ট্রান্সপারেন্ট জোন উইথ রেসপেক্ট টু আই উই হ্যাভ টু হাফ পিরিয়ড জোনস, অ্যান্ড হুইচ টু, কোন দুটো, ফার্স্ট অ্যান্ড সেকেন্ড, রাইট? আই হ্যাভ এক্সপ্লেন্ড ইট ফার্স্ট অ্যান্ড সেকেন্ড। নাও ইউ কন্টিনিউ দিস ওয়ান, এটাকে কন্টিনিউ করো, ঠিক আছে, এটাকে কন্টিনিউ করো। লিমিট, সো এখানে আমি লিখি উইদিন দ্য সেকেন্ড জোন বা সেকেন্ড, within the second circle I write, within the second circle, because you know that the second circle is opaque, right? Second circle টা তো opaque ছিল। within the second opaque circle, second was opaque, you remember, alternate zones were blocked. Within the second opaque circle, again we have the, ওখানে কারা থাকবে, we have the third and fourth half periods, ঠিক আছে? Within the first transparent zone with respect to I we have two half period zones, that is the first and the second. Within the second opaque circle we have the third and the fourth half period zone, right? And within the third transparent circle, and now within the third one, third is transparent again, within the third transparent circle we have the, which one, third fourth হয়ে গেছে, so fifth and sixth, now we have the fifth and sixth half period zone. So within each and every circles, previously যেটা একটা জোন ছিল, previously which one was a single zone, but now within that you have two zones, এটা হচ্ছে তোমার, so this is the concluding remark, that previously which one was a single zone, but now you have two zones over there. So you have fifth and sixth half period zone and so on এবং এইভাবে এটা চলতে থাকবে and so on. Got my point? তাহলে এখন কি হবে, so net amplitude, so what is the net amplitude at where at I dashed? So net amplitude at I dashed, I call it A dashed, and you see that it was A1, so whatever was A1, now within A1 you have two zones, that is it will become A1 minus A2. Now you see that the second one is blocked, so 3 and 4 will be blocked. এই ভালো করে খেয়াল করো, have a good look over here, এটা ভালো করে খেয়াল করো। so এই জায়গাটা একটা, I should box over here, একটা box থাক, just note over here, after A1 A2 was blocked, second circle was blocked, so you have 3. But now within the third circle, which zones are there? Within the third transparent circle, we have the fifth and the sixth half period zone, right? Within the first transparent zone লেখাটা উচিত না এখানে, I shouldn't write zone over here. Within the first transparent, I should write circle. Within the first transparent circle, we have the first and second half period zones. তাহলে এবার যে এই যে, তাহলে এই কন্ট্রিবিউশনটা কি হবে, ফার্স্টটা হয়ে গেছে, ফার্স্ট এন্ড সেকেন্ড ইজ ওপেক, সো দ্য থার্ড এন্ড ফোর্থ উইল নট কাম ইনটু দ্য পিকচার। এই দেখো থার্ড এন্ড ফোর্থটা পিকচারে আসবে না, থার্ড এন্ড ফোর্থ উইল নট কাম টু দ্য পিকচার বিকজ দ্য সেকেন্ড জোন ইজ অলরেডি ব্লক, সেকেন্ডটা ব্লক করা আছে। তাহলে নেক্সট কে আসবে, 5 আর 6 আসবে। So 5 and 6 will come into the picture. And the significance of the negative sign, I guess you understand. So now you say that this intensity or amplitude has increased or decreased. So এখন বলো এটা বাড়লো না কমলো. So definitely এটা amplitude কিন্তু কমে গেছে. The amplitude has decreased. Why the amplitude has decreased? Because here you had only the plus terms only the plus terms, but here you see that there are contribution from the negative terms also. And in addition to that, A3 is missing. এবং তার সঙ্গে দেখো আরো addition হয়েছে A3 টা কিন্তু missing আছে এখানে. Your A3 is missing over here. And you have some negative terms also. Right? Understood? So from here your conclusion is, তাহলে এখান থেকে তুমি conclude করতে পারো, therefore A dash is definitely less than A. Therefore A dash is definitely less than A. Okay? So this is a very important conclusion that you draw over here. So এই দুটো কিন্তু খুব important conclusion যেটা তুমি এখানে draw করতে পারছো. These two are very important conclusions that you draw right now. Okay? Now let us continue this procedure. This procedure means let us now take the point of observation closer to the plate further at I double dashed. So now let me take at the point I double dashed such that this becomes k square by 3 lambda. যাতে কিনা এটা k square by 3 lambda হয়ে যায়. Okay? So let us do that one. So আবারও লিখছি আমি. Next we consider a point. Next we consider a point. Which one? Next we consider a point I, capital I, double dashed, such that, এমন ভাবে নিলাম, such that pi double dashed is now k square by 3 lambda. K square by lambda was the position of I, so k square by 3 lambda, right? So এরকম ভাবে আমরা লিখলাম, ঠিক আছে? Now this pi double dash in the same manner, I will not break the mechanism. এইভাবে লিখছি k double dash square. So I write it k double dash square by lambda, and this is k square by thrice lambda. So that comes out to be k double dash equals to k by root over of 3. Just check me. So this was k by root over of 2 and now it is k by root over of 3. So therefore you have your Rn is equals to some k root over of n. We know it. This one is Rn double dashed, so this one will be double dashed. Okay? So here I have Rn double dashed. So this is k by root over of 3 multiplied to root over of n. That's the relation that I have. এই রকম একটা relation. তাহলে এখানে দেখো কতগুলো থাকবে at the value of k. So here I can write that R1 double dashed is equals to k by root 3. R2 double dashed is equals to k by root 3 into root 2. Root 3 into root 2. And then finally I have R3 double dashed. That one comes out to be only k. Okay, so now you see that this distance, let me box up this one as per our previous convention, R3 double dashed is equals to k. তার মানে এখন তুমি দেখো, if I shift the position capital I to the position of I3, so then within a distance of k, where there was a single zone, যেটা আগে একটাই zone ছিল up to the distance of k, look at equation 1, there was only a single zone, but now you see that at a distance of k, it is the radius of which zone? So k is the radius of which zone? K is the radius of the third zone. So that means that within the first transparent zone, তাহলে প্রথম transparent zone এর মধ্যে এখন কিন্তু কটা zone আছে? How many zones are there? There are 3 zones over here. R1 dashed, R2 dashed and R3 dashed. When I have shifted the point to I double dash such that I double dash value comes out to be k square by 3 lambda. তাহলে এখন দেখো প্রথম জোনের মধ্যে কিন্তু তিনটে হাফ পিরিয়ড জোন ঢুকে আছে. Within the first zone we have 3 half period zones, right? So let me just copy this statement and I will just make requisite changes. অনেকটাই চেঞ্জ করতে লাগবে. I need to make some good amount of changes. So within the first transparent circle we have 3 half period zones. That is the first, comma, second and third. First, don't start writing now, you will write later on. First, comma, second and third. So তিনজন এখানে থাকবে. তারপরে within the second opaque circle we have the, so third of the হয়ে গেছে, so definitely we will have fourth, fifth and sixth within the opaque one. Fourth, comma, fifth and sixth within the second opaque half period zone. এটা থাকবে। within the third transparent circle we will have the কোনগুলো থাকবে বলো এখানে, we will have the seventh comma 8th 7th 8th and 9th half period zone and so on. Got my idea? 7th 8th and 9th half period zone. তাহলে so now you can write over here, so the net amplitude or intensity, so the net amplitude where, so the net amplitude at your this one is I2 double dashed, so I call it A double dashed. So you have the first contribution is A1 minus A2 plus A3. This one will be considered for first, second and third. Then the fourth, fifth, sixth will not be considered because those circle has been blocked initially. ওটা initially block করে দেওয়া আছে. The second one is blocked. Second is the opaque circle, and again you have the transparent circle. So it will start from 7, A7, A8, A9, and then you have some plus dot dot dot. So that is what you have over here. Understood? And now you come out with a very important and strange condition that this A double dash, is, you come out with a strange condition that A double dash is lesser. A double dash is lesser than A, but it is greater than A dashed. So therefore, just to look at this equation, you have more number of positive terms over here. Negative term দেখো প্রত্যেকটা ব্র্যাকেট থেকে একটা করে আছে. From each brackets you have one negative term, but the number of positive terms have increased over here. Positive terms have increased over here. Okay, from each bracket previously you look at this one, এটার দিকে যদি দেখো, if you look at A, all are positive, right? If you look at this one, positive negative alternate. And if you look at this, you see that in each bracket there is 2 positive and 1 negative, 2 positive and 1 negative. So definitely this contribution is greater than that of A dashed. So therefore this A double dashed is definitely greater than A dashed, but A double dashed is less than A. ঠিক আছে না? A double dashed will be greater than A dashed, but A double dashed will be less than A. That is very obvious. সেটা তো হতেই হবে. That is very obvious over here. Understood properly? I hope that you are getting it. So নিশ্চয়ই বুঝতে পারছো. So you are getting all the ideas over here. তার মানে যেটা হচ্ছে আমাদের, so from here the basic conclusion that we draw over here is that, so A double dash is greater than A dashed, but A double dash is less than A. তার মানে this one is my point of I. Don't draw this. এটা একো না. This one is my I dash and this one is I double dashed. So here I have what? I have bright, right? This one I can consider bright. This one again I can consider bright, right? But that is the maximum intensity. And this one I can consider dark. Dark means not complete dark, but lesser intensity. Okay. So this point is a bright point I, and then this I2 double dash is a bright point. Why do I call so? Because your I double dash or A double dash is greater than A dash, but this A double dash is less than A. মানে মোদ্দা কথা হচ্ছে A dash এর ইন্টেন্সিটিটা সবথেকে কম. The intensity of A dash is the least one, and the intensity of A double dash is greater one. So that is why I can say এই যে মাঝের পয়েন্টের ইন্টেন্সিটিটা কম, বিকজ এখানে প্লাস মাইনাস আছে, বাট এইটার ইন্টেন্সিটিটা বেশি এই দুটো, বিকজ the first one has only positive term and here you have in a particular parenthesis you have 2 positive along with a single negative. তার মানে এখানে নেগেটিভ পজিটিভ কন্ট্রিবিউশনটা বেশি. The positive contribution is more over here because there are 2 positive term and 1 negative term, and this is what I call the bright point. This one I call the bright point. এবার যদি intensity of the bright points আমি compare করি, if I compare the intensity of the bright points, then what do I see? So if I compare the intensity of the bright points, so then this is the maximum bright point. So this is the maximum bright point, যেটাকে তোমরা central maxima or the principal maxima you call it, and this one is the first bright point. Okay, this one is the maximum, you may call it the central bright point, and this one you may call the first bright point. And similarly there will be some other points also such that I চারটে dash, so there are 4 dash. So this way you can proceed the situation. I hope that you are getting it. So আশা করি তোমরা এখান থেকে বুঝতে পারছো, so you are able to understand the issues over here, right? So let us now just finally conclude the issue. তাহলে এবার আমরা ইস্যুটা এখানে কনক্লুড করে দিই। So let me just conclude it. So I write it. So my conclusion is that we find that the intensity at I double dashed is greater than I dashed, but less than I. Okay, so we conclude, final conclusion. So we conclude that the points like capital I, comma, I double dashed, comma, I 4 dash, comma, dot will correspond to more intensity, than whom? Will correspond to more intensity than I dashed, comma, I, which one? I triple dashed, comma, dot. Okay, so I dashed, I triple dashed থেকে I double dashed, I 4 dashed will be more intense points. Okay, right? সেই জন্যই that is why I is called the point of maximum intensity. The point of maximum intensity is called the point of maximum intensity is called, এটাকে কি বলবো, is called the first focus. The point of maximum intensity is called the first focus of zone plate. It's called the first focus of zone plate. এটাকে first focus বলে। And now similarly the other points like তারা থাকলো I double dashed, comma, I quadra dashed, comma, dot. ওরা কে ওরা? Who are they? Are called the second, comma, third, are called the second, comma, third focus, are called the second, comma, third, comma, dot D, are called the second, comma, third, comma, dot focus of the zone plate, right? And this actually leads to the final result that a zone plate has multiple foci. The zone plate has multiple foci. See, this is the question, that zone plate has a multiple foci, so you need to answer it in this way. And this treatment is my own, so that is what I have derived this for a clear cut understanding of the problem. You will look at the books are not quite clear, a few of them are clear, but I have derived it in my own way. আমি একটু চেঞ্জ করেছি, so I have changed it in some way. Basically in the books you will not find this, এই I dash টা বইগুলোতে থাকে না, they just skip this I dash, but I have included this such that you have a clear picture that which one are points of maximum intensity and which are of minimum intensity, and the points of maximum intensity are called the foci, এবং maximum intensity ওয়ালা পয়েন্ট গুলোকে আমরা foci বলি, other are minimum. Okay, so this is how the zone plate has a multiple foci, not from this relation Fn is equals to Rn square by n lambda, use different values of n and get different focus. No, here using different values of n will lead to single focus only, right? But so here you see that you have to shift the point I inward towards the zone plate, and then you can have more number of zones within a particular circle, and that is how you get the concept of multiple foci. So এইভাবে multiple foci এর কনসেপ্টটা পাওয়া যায়। So I hope that you have understood the situation and also enjoyed the scene. And now I will go through one or two problems on the half period zones, not on zone plate. The problem on zone plate has already been done. So now I will show you a problem from the half period zone. So actually that would have been shown on the last class, but because the last class was too lengthy, so I just concluded the last session, and here I will include the problem in this particular class. So let me try to do that. Just wait, just give me some minute to search the problem. আমি একটু প্রবলেমটা সার্চ করব, আমাকে একটু টাইম দাও একটু সার্চ করার জন্য, একটু সার্চ করব. If I find it, okay, so then only I can go through it. Yes, I received the question. I got the question. Let me just type it over here. A plane wavefront of wavelength 600 nanometer is incident on a circular hole. This one I will do later on. এটা আমি পরে করছি, তার আগে আরেকটা আছে. I have another one before this. Let's try to do this. Light of wavelength 500 nanometer. Light of wavelength 500 nanometer. Light of wavelength 500 nanometer is incident on a circular hole. Is incident on a circular hole of radius 1 centimeter. Of radius 1 centimeter. Okay, of radius 1 centimeter. How many half period zones are contained in the circle? How many half period zones are, how many half period zones are contained in the circle? Are contained in the circle. How many half period zones are contained in the circle if the screen is placed at a distance 1 meter? If the screen is placed at a distance of 1 meter. Okay, if the screen is placed at a distance of 1 meter from the wavefront. So কটা half period zone ওখানেতে তৈরি হবে? How many half period zones are there within that wavefront? So this would be an interesting problem. একটা ইন্টারেস্টিং প্রবলেম এখানে আসবে, দেখা যাক কি বলি, কি পাই আমি এখান থেকে. So light of wavelength 500 solution. Let me write the given parameters that speaks up a lot. So কি কি দেওয়া আছে সেটা আগে ক্লিয়ার করে নাও. So radius of the hole is 1 centimeter. So this is something circular aperture type. How many half period zones are there, and this distance is the p that used to write on my last class. এটা হচ্ছে p distance টা যেটা আমরা লাস্ট ক্লাসে লিখেছিলাম. Now the radius of the half period zones, how many half period zones? So radius of the half period zone, I have a formula I recall. Radius of a half period zone, I use the approximate formula. আমরা approximate formulaটা ইউজ করছি. Radius of any half period zone was given by an approximate formula of root over of most probably p pi lambda. So এটা formula ছিল. This was the formula that p pi lambda. This was the formula for the radius. Okay, I guess I am correct. If not, I will do something else. Now the question is some difficulty. এটা p ছিল না, most probably this was some n. Let me check from the last day's class note. Last class note টা চেক করে নি. Last class note, let me check it. There I will find, I guess. No, I get it nowhere. It's সময় লাগবে, হ্যাঁ, just give me a minute. I need to do it yourself, myself. আমাকে নিজে করতে হবে. Yeah, it was it was n lambda p. It was n lambda p, not pi. Pi লিখে দিয়েছি by mistake. I have written pi. It was n lambda p. Yeah, it was np lambda. So pi shouldn't come until and unless I go for the area. Pi shouldn't come. So sorry for that. So let me just calculate this n. My idea will be clear. So এখান থেকে n বের করো, তাহলেই কাজ হয়ে যাবে. rn square ছিল এটা. So this one is your rn square. let me try to calculate the radius of the oh, this R is something else. I shouldn't write this. এই আরটা এখানে লিখো না রে, এটা তো অন্য আর। দিস ইজ দ্য রেডিয়াস অফ দ্য হোল, ইউ জাস্ট রিমুভ ইট। এই হোলের রেডিয়াস লেখার দরকার নেই, নো নিড টু রাইট দ্য রেডিয়াস অফ দ্য হোল, নো নিড টু রাইট ইট। Radius of a half period zone is given by this formula. Okay, এখানটাতে তুমি লিখতে পারো, here you can write, first of all try to understand the problem, আগে প্রবলেমটা বুঝে নাও। So these are the half period zones that you have, so these are your half period zones that you have, okay? So these are your half period zones, and this way you can extend up to the nth zone over here. এভাবে তুমি nth zone অবধি extend করতে পারো, you can extend up to the nth zone in this particular way, right? You can extend up to the nth zone. Suppose this is the nth zone that you have, and this radius is actually provided to you. এই রেডিয়াসটা তোমাকে দিয়ে দিয়েছে, the radius of the hole, the radius of the circular hole has been provided to you, okay? Means you have to understand that the maximum or the highest half period zone, সব থেকে শেষ যে হাফ পিরিয়ড জোনটা, the extremum half period zone, the radius of the extremum half period zone and the radius of the hole must be same. I hope that you are getting it. এটা নিশ্চয়ই বুঝতে পারছো। the radius of the hole, তোমার যে হোলটা যেটা আছে এটা হচ্ছে তোমার হোলটা, this is the hole, the circular aperture, and within this the half period zones are there from the wavefront, right? So the last half period zone that can be accommodated over here, মানে nth half period zone that can be accommodated over here should be of equal radius that of the whole, and if the radius of the half period zone is greater than that of the whole, so then that will not come into the picture. এবং যে সমস্ত হাফ পিরিয়ড জোনের রেডিয়াস তোমার জোনের বড় আছে, গ্রেটার দ্যান দ্য সার্কুলার অ্যাপারচার, দ্যাট উইল নট কাম ইনটু দ্য পিকচার, ওকে? আই হোপ দ্যাট ইউ গট ইট। সো সেটাই আমি এখানটাতে লিখছি। সো এখানটাতে লেখো radius of the extremum half period zone, মানে সব থেকে লাস্ট যেটা হবে, that means the nth one is equals to what? Is equals to radius of the circular hole, radius of the circular hole or aperture, whatever you call, বলে গেল radius of the circular hole or aperture, মানে লাস্ট হাফ পিরিয়ড জোনটা হোলটা দিয়ে ঢুকবে, the last half period zone that will enter through the hole will have the radius equal to that of the hole. So that is very much understandable. এবার প্রবলেম হয়ে যাবে। So now you have no difficulty. So radius of the extremum half period zone is given by the formula of root over of np lambda, and the radius of the circular hole over here is given by 1 centimeter. 1 centimeter means 10 to the power minus 2 meter, because here I am using the meter scale. So I have np lambda, that one equals to 10 to the power of minus 4, or n will come out to be 10 to the power minus 4. P is 1 meter and the wavelength of light is 500 nanometer, that is 500 into 10 to the power of minus 9. So that gives me 10 to the power 5 divided by 500. 10 to the power 5 divided by 500 মানে হচ্ছে আবার 1000 divided by 5. 2 zeros gets cancelled, so basically you have 200 over here. So that's come out 200. So 200টা half period zone এখানে থাকবে, there will be 200 half period zone, and from here this is the realistic problem, এটা একটা সত্যি ঘটনা, this is the realistic problem. So from here you understand that a radius of 1 centimeter will accommodate 200 zones within it. Just you take your scale, I have also taken a scale in my hand, আমিও একটা স্কেল নিয়েছি, and I am looking at 1 centimeter, যে 1 centimeter কতটা ডিসটেন্স হতে পারে, how much distance is 1 centimeter, I am currently looking at that, and you also look it. So within that 1 centimeter hole, which is quite a large diameter, বেশ বড় diameter কিন্তু 1 centimeter, so within that 1 centimeter hole you will find how many zones, তুমি ওখানে কতগুলো জোন পাবে, you will have 200 zones over there. So ওখানে তুমি মোটামুটি 200টা জোন ওখানে পেয়ে যাবে, you will get 200 zones over there. I hope you got the first problem. And the last one that I will solve for you, আমি আরেকটা করে দিচ্ছি। So this is where some application of the last days words that I have said. আমি last দিন যে কথাগুলো বলেছি তারই application এটা. The next problem is a plane wavefront of light, a plane wavefront of light of wavelength 600 nanometer is incident on a circular hole and is received on a screen and is received on a screen 50 centimeter away find the diameter of the hole so that the intensity of light on the screen is 4 times the intensity when whole wavefront is not obstructed. When whole wavefront is not obstructed. So একটা situation হচ্ছে there is a situation when the entire wavefront passes and there is a situation when a part of the wavefront is blocked. By it. এবং তুমি জানো যে ব্লক করে দিলে ইন্টেন্সিটি বাড়ে, এটা জানো তো, you know this from the last classes that if I block it the intensity increases because you see that if I take the entire wavefront, যদি পুরো wavefront নি, so the intensity at this particular point is how much? It is what? The intensity is over here a1 square by 4. Now if I start blocking it, so only this much is allowed and everything else is blocked. পুরো ব্লক খেয়েছে এখানে, the entire thing is blocked. I block everything and I allow to pass only through this circular zone. So then the intensity that reaching at this point, you know, it is only a1 square because there is no mutual destruction. So destruction এর কোনো কেস এখানে নেই, তাহলে শুধুমাত্র a1 square আসবে, it is a1 and a1 square. But if I pass another zone over here, so then the net intensity will come out to be what? It will be a1 minus of a2 and this will be nearly 0. So it will come out to be nearly 0. Not exactly 0 because a1 is greater than a2, but that will tend towards 0. But again if I take another zone over here, so then it becomes a3 over here and then again you get a maximum. But that maximum will be lesser than this first zone only. So প্রথম জোনটা থাকলে যে লাইট আসে that is the maximum of all, and second zone it is minimum, and the third zone is exposed, then it is another maximum. But that maximum is of reduced intensity, and that is why you used to say that the diffraction maxima are of reduced intensity. So as you move away from the center, the intensity you see it is diminishing, right? You have seen in the Fraunhofer pattern also, and it is true in the Fresnel class also. ঠিক আছে, আচ্ছা তাহলে এখানটাতে কি বলেছে? সেখানে বলেছে you blocked everything and you just expose one of them such that the intensity becomes 4 times. 4 times why? You know that you find the diameter, so the intensity of light on the screen is 4 times the intensity. So 4 times the intensity means you have allowed only one half period zone. So 4 times the intensity means only one half period zone is allowed. So এখানে আমি লিখছি for an unobstructed wavefront, intensity at P, for an unobstructed wavefront, intensity at P is equals to a1 square by 4, right? আর হচ্ছে for an obstructed wavefront where only first half period zone is allowed to pass. Okay, for an obstructed, everything is obstructed, you allow only one half period zone where only first half period zone is allowed to pass. So then intensity at P, please consider my handwriting, then intensity at P is a1 square. যেখানে a1 টা কি আছে? a1 is the amplitude from where? First half period zone. a1 is the amplitude from the first half period zone. Got my point? আচ্ছা এবার দেখো কি স্টোরি বলেছে, দেখো a plane wavefront is incident and is received on a screen 50 centimeter away. So I write it over here that what is given parameters, এখানে কি দেওয়া আছে লিখে নাও. So given lambda is over here 600 nanometer বলেছে, it is 600 into 10 to the power minus 9 meter. Screened distance, that is P, I used to write, which is 50 centimeter. So 50 centimeter means 50 into 10 to the power minus 2 meter. Find the diameter of the hole so that the intensity is 4 times of this one, right? So definitely the diameter of the hole will be equals to the diameter of the, so here you must have this one, diameter of the hole is equals to what? Diameter of whom? Diameter of the hole is equals to diameter of whom? Diameter of hole is equals to diameter of what? Diameter of hole equal to diameter of first half period zone. First half period zone, because you allow only one half period zone, and in the last problem it was nth half period zone because you allow n number of zones. Okay, last time nth half period zone chilo okhane and n was 200, but this time you allow only the first. And how do you understand the first? Because it is by problem. It is by problem, and here এখানে একটা কথা লিখতে হবে, which is 4 times of unobstructed wavefront. 4 times of unobstructed wavefront, because you need to satisfy the problem over here. 4 times কখন আসে? 4 times the intensity. 4 times the intensity of not obstructed is only when the first half period zone is exposed. So that is how you can get the problem. তাহলে এখান থেকে তোমার প্রবলেমের সলিউশন হচ্ছে diameter of the first half period zone, আমরা ডায়ামিটার দিয়ে না করে রেডিয়াস দিয়ে করি। রেডিয়াস অফ দ্য হোল is equals to, radius of the hole is equals to what? Radius of the hole is equals to radius of first half period zone, and radius of first half period zone এর ফর্মুলা আছে Rn is equals to root over of np lambda. So Rn is equals to root over of np lambda. So n is your first half period zone, that is only p lambda. So it is 50 into 10 to the minus 2 into 600 into 10 to the minus 9 root. So let me just calculate this. I don't have the result actually with me. So 50 into 600 into 10 to the minus 11. So I just take a square root of this. So that comes out to be something, and that I should multiply by 2. So my answer finally comes out to be 1.09 into 10 to the power minus 3 meter. That actually means 1.0. Oh, sorry. What did I do? একটু প্রবলেম হয়েছে। 1.09 is the diameter. I have calculated the diameter directly diameter calculate হয়ে গেছে। So first of all I should write it to be some 5.477 into 10 to the minus 4 meter. So that is the radius. So finally diameter টা কি হবে? So diameter of the hole will come out to be 2 times of this. So 2 times the radius, and that comes out to be 1.09 into 10 to the power minus 3 meter চলে আসে এটা, and that basically means 1.09 millimeter, because 10 to the power minus 3 meter মানে হচ্ছে 10 to the power minus 3 millimeter. Okay, 10 to the power minus 3 meter means it is actually millimeter scale. So that is the diameter of the hole. So the hole should be, now you see 1 millimeter. You look at your scale, you will understand that what is 1 millimeter. So 1 millimeter means হচ্ছে the entire thing is 1 centimeter, মানে 0.1 centimeter. Look at your scale and you see 0.1 centimeter. Okay, so 0.1 centimeter. So that is the diameter of the first half period zone. সেটা first half period zone এর diameter হচ্ছে এরকম. So in this realistic problem, when you see that the observation distance is also 50 centimeter over here, so that also plays a game. So you just get some ideas of what is going on. So কি হচ্ছে তার একটা আইডিয়ার জন্য এই দুটো প্রবলেম করলাম, because these two problem helps you to understand the facts in a better manner. So that's why I have selected 2 numerical examples. Now you are encouraged to do some more numerical examples and go through the situation in a proper order. I just say that if you go through more examples, you will understand the things in a better manner. তুমি যদি বেশি করে এক্সাম্পল সলভ করো তাহলে কিন্তু তুমি ভালো করে জিনিসগুলো বুঝবে, you will understand it in a better manner. So here I am winding up the lecture for this class. Thanks to all of you for your kind